Welcome back, students, to another tutorial video for MM101. Now, apologies firstly for the delayed upload for the week 9 tutorial video. So this week we are focusing on auxiliary view. Auxiliary view means extra view, and so you have your 6 principal views, and sometimes you do not get the true shape of a particular object or a drawing within those 6 principal views. This could be mostly be due to inclined surfaces. So in such cases you need to draw auxiliary views so that you are able to view the true shape of an object. So that pretty much answers the first question. Okay, so the focus for this video will be on the second question. So you are given a very simple drawing, and for that you'll have to draw a complete auxiliary view so that the shaded region here, it appears as a true shape. Now it is most likely that this shaded region is a inclined surface, hence in the 2 views given it is not shown as a true shape. Now the rule is, you have learnt in your lectures what are the true rules to determine, or the 2 rules to determine the true length. So if for any object, if all the sides are true length, then that object becomes a true shape. Right, so keeping that in mind, let's proceed. Okay. So I have drawn up a little a short PowerPoint video which demonstrates the solution for this week's tutorial. Okay, so let's get this rolling. Okay, so there is a question. Now we have covered extensively orthographic drawings. So first of all, your first task would be to determine, out of the 2 views given here, which one is the plane and which one is the front view or the elevation. Now in this case, you're just given 2 objects. In between there is a reference line, and you have H above the reference line, and below it you have a V. H implies for horizontal plane, whereas V implies for vertical plane. So we have covered this very much in detail, and you should know that the horizontal plane will always contain the plane or the top view, and below it is the front elevation. Right, so in this case, that is your plane or the top view, and below the reference line, inside the vertical plane, you have your front view. Now the very simplest approach I'd like you to take in order to complete this is, you can always pause this video and finish the activities I give in between. So just very simply, without even considering this shaded region, if you visualize this forms a rectangle. Okay, the 2 views are a rectangle. So I would want you to draw the isometric view of this, okay, or a simple plane and a simple elevation. Okay, and the next slide will reveal the solution. Now to start off with, use to draw isometric, just recapping, this is part of revision. So you start off with your isometric axis. Okay, the 2 sides are inclined at 30 degrees. Okay, and then it's very important to have your drawing instruments. Okay, in my case I had to borrow all these compass, pencil, pen, and even the set squares from my wife, and she was very willing to lend it to me. So, and as engineering design students, it's very handy to keep these drawing instruments with you. So that is my solution. So viewing it from the top, that's my top view, and reviewing it from the left hand side, that is my elevation or the front view. Now just going back a few slides, now you have to pretty much draw this shaded region in that 3D view or 3D isometric view. Now please go ahead and attempt that as well. Okay, so there you go. So that is the shaded region represented inside that object or a 3D isometric view. Okay. Now the next step here is, so now I am starting to attempt the question itself. So what I will do is I will start labeling all the corners or the top corners of this object. Okay, so I'll start in a clockwise direction. Okay, A, B, C, and completing that shaded region D, E, and F. So the shaded region, which is inclined, so it forms a triangle represented by D to E, E to F, and F to D. Right. So what is the next step you will do is you will take these labels and represent them on your plane. Right. So which I have done here. So look at it from the top. So you have A, B, same way as you had done on your 3D isometric view. And similarly, you will also represent those labels, okay, which you have done for each corner. Represent it on the, or mark it out on the front view or the elevation as well. So how I have done this is A is in front and B is behind A. So I have put A followed by a slash and then B. Okay, that's F and D to C. Okay, so D is in front and C is behind, and this is E. Okay, so I have labeled all the corners or the top corners of this object. Now similarly I will label all the bottom 4 corners. So to avoid confusion, I have used numbers instead of alphabets. So 1 and 2 is directly below B, so it's not shown here in the isometric view, and 3 and 4. So the 4 corners have been labeled, and similarly you will represent that as well in your plane followed by the elevation. So all the corners of the orthographic view are now labeled. Okay, now what is the next step? So we will just, for the time being, we will just focus on the inclined plane for which we have to draw the auxiliary view, for which we have to get the true shape. Now let's just focus on this triangle formed by the 3 lines D to E, E to F, and F to D. Okay, as per your lectures and what you have learned about true length, okay, so the way we define true length is, so if a line appears as a point in one view, in the other view, it is the true length. So for example, if a line appears as a point in the horizontal plane, so that line which is in the vertical plane becomes a true length. That's rule number 1. The second rule is, if a line appears parallel to the reference line in one view, then in the other view it is the true length. Okay, so if a line appears parallel to the reference line in the horizontal view, therefore that line in the vertical plane is the true length. So if we try to apply that rule here on this triangle D to E, E to F, and F to D, so let's see. So in the horizontal plane, is F to D parallel to the reference line? No, it's not. Okay, so in the other view it can't be regarded as the true length. Right. Let's say in the horizontal plane D to E, okay, it's not parallel to the reference line, therefore D to E in the vertical plane is not the true length. Okay, now let's consider the vertical plane. So if you look at the vertical plane, okay, or everything contained inside the vertical plane, let's see, F to D. F to D is parallel to the reference line. So in the other view, which is the horizontal plane, F to D is the true length. Okay, so as I have labeled here, okay, just repeating myself. So F to D in the vertical plane is parallel to the reference line. Therefore, F to D is the true length in the horizontal plane. So the next step is, what we will do is we will extend this true length line. okay, as I have done here. So F to D is the true length. You extend this true length line, as well as parallelly you extend a line from E. Right. Now following this, what you do is then some distance apart you draw a new set of reference line. So the lines which I have extended initially from F to D as well as from point E, they are called projection lines. Okay, I projected them outwards. And now always remember that reference line and projection lines are always perpendicular to each other. In other words, they are at 90 degrees. So that's why I have put these labels here. Okay, now how do we determine H and V? So a reference line, I normally try to keep in mind that reference line is like a boundary, right? As soon as you cross over, you are changing planes. Okay, so right now whatever work you were doing, extending the lines, finding the true length, that was all done inside the horizontal plane. So that's why to the left of the new reference line we have drawn, I have written H. So beyond, as soon as you move to the other side, it becomes, your plane changes, so it becomes a vertical plane, right? So please do keep that in mind. Okay, moving on from here. So in the next slide, I have labeled my new reference line as number 2. The initial one I have labeled as 1. Nothing more to it. Okay. Following on from this, okay, now I need to draw in my new vertical plane, which is to the right of the second reference line or the new reference line we have drawn. So what I will do is I will move 2 reference line backwards. Okay, it's like 2 steps backwards. So the new reference line which you have drawn and the second reference line you have drawn, you go prior to it, right? So you put the compass needle on the reference line and you take measurements backwards. So in this case, the measurements we have taken are only concerned with point D, point E and point F. Okay, so what is the distance from the horizontal line, from the reference line to point D? Measure it out and then you mark it out on the new reference line. Okay, so in other words, what we are doing is, if you need to draw in the vertical plane, you need to get your measurements from the vertical plane, right? So make your work easier to understand. So point D we have measured out in the vertical plane with respect to the reference line. Okay, so your compass needle, put it on the new reference line and mark out in the new vertical plane. So that is point D. And similarly, you measure the distance from the reference line to point E, mark it out there as well. Okay. So what happens is, you'll notice that from the reference line to point D, from the reference line to point F, it is the same distance, so it appears as a single point. Okay, and then what you do is simply join the 3 dots. You know how they are joined? D joins to E, E joins to F, and F joins to T. So there you go. Now you'll end up with a straight line. Now this straight line is referred to as the edge view. Okay. So for that inclined surface, you can put it this way, that you have rotated that object in such a manner that the triangle which was there, or that inclined surface which was present, you are viewing this as a single edge. Okay, so this is called the edge view, or this is also known as the primary auxiliary view. So after the edge view, so you will move ahead, and this is what you're required to do. So now from the edge view, you will project projection lines, again keeping in mind, so that's your edge view there, D to E, E to F and F to D. So 90 degrees to the edge, we will project projection lines. In my case, I have projected it downwards. So that means that now the true shape which I will be getting will be somewhere down here. Okay. Now you will need to draw a new set of reference line. As I said earlier, the rule is that projection lines and reference lines are always drawn at 90 degrees to each other. Okay, so the edge view, if you recall, you had drawn it in the vertical plane. So above the new reference line you will write V, okay, because it's the same plane. As soon as you cross over, you're changing planes. So below this new reference line you will now write H. So this becomes your third. The newest reference line which we have drawn is the third reference line. Okay, above the reference line is the vertical plane, below the reference line is the horizontal plane. So now within the vertical plane you have your primary auxiliary view or the edge view, and now we need to draw in the horizontal plane. Therefore we will have to take measurements from the horizontal plane. Okay, in other words, two reference line backwards, that is where you will take your measurement from. So the third reference line, and prior to it you have the second reference line. So put the compass point or the compass needle at the second reference line and take measurements backwards. So let's start with D. So measure the distance using the compass from the reference line to point D and then plot it in the new horizontal plane. Okay, so compass needle on the reference line number 3 and mark out point D. Similarly for point E, okay, measure the distance, plot it. For point F, again measure the distance and plot it. So now you have your 3 points, D to E, E to F and F to D. Okay, so then you join them. So you know that from your initial isometric drawing, you know that D joins with E, E joins with F and F joins with D. Okay, hence this is your secondary auxiliary view, or in other words your true shape. Now how do we confirm that this is a true shape? In order for an object to be a true shape, all the lines need to be true length. So let's look at this. D to E, okay, E to F and F to D, they all need to be true length. Okay, so I'll go a few slides backwards and look at the edge view. So we will just consider this new reference line number 3. Okay. So D to F appears as a point in one view, therefore D to F is a true length. Okay. Similarly, D to E is parallel to the reference line here, therefore D to E is the true length. And similarly, E to F is parallel to the reference line, which is here. When I say reference line, I mean the new reference line. Therefore, E to F is your true length. So now we have proved that D to E, E to F and F to D, all 3 of them are true length. So therefore, this shape has to be a true shape. So that's done. So now what you have done is you have rotated the isometric drawing as such that only this inclined surface here is viewable as a true shape. Okay, but the question was asking for a complete auxiliary view. So how do we do that? In a similar way. So initially we were just focusing on the triangle DEF. What you will do is take all the points across. When I mean all the points, I mean I to F as well as the bottom 4 corners, which is 1, 2, 3 and 4. The process is simple, so I'll quickly go over this. So for your primary, in your primary auxiliary view, plot all the points as I am doing here. Okay, something wrong with the color of this. So plot all the points A, B, C, D and E. Now if you are confused how do I join this point, just look at your initial drawing, okay, your initial isometric drawing. So you'll know that A joins with B, B joins with C, C joins with D, D to E, E to F, and F to C again. Okay. And similarly, you plot the bottom four corners 1, 2, 3, and 4. Okay. Please be mindful where your measurements of these come from. Okay, they are always two reference lines and back. Okay, and or the other way of remembering this is if you want to draw in the vertical plane, therefore you have measurements have to come from the vertical plane. Okay, after this, there you go. You join all those points. Okay. Okay, A joins with 1, B joins with 2, 3 joins with C, and E joins with 4, which is what I have shown here. Right. So this is your primary auxiliary view, okay, together with the edge view. And then, as we did in order to get the true shape, project all these points downwards to get your true, or to get your secondary auxiliary view. Okay, so as you can see here, so it's very easy. You have your drawing instruments, in particular the set squares. It will help you to ensure that all the lines which you project are parallel to each other. Okay, so once you get all the points, okay, so you need to draw in the horizontal view. Okay, so 2 reference line backwards, so that's number 3, number 2, and all your measurements will come with respect to the reference line and backwards. Okay, so there you go. Right, so what I'm doing here, I'm just plotting all the points in my secondary auxiliary view, the top corners which are A, B, C, D, E, and F, and after that I just start joining them. Okay, so A joins with B, B joins with C, C joins to D. Okay, you know D, A, and F, they form the triangle, and F joins with A. Okay, and following that, I plot all the bottom 4 corners, which are 1, 2, 3, and 4. Okay, sorry about this image; it's a bit blurry. So A joins with 1. There you go. B joins with 2. Okay, I have shown it as hidden lines because they are behind. Okay, so C joins with 3. And E joins with 4, as well as 1 to 2, 2 to 3, 3 to 4, and 4 to 1. They join to form the bottom of the isometric drawing. So this is your complete auxiliary view together with the true shape. Okay, so in this image, only D, E, and F, the triangle which is formed, or that shaded region, or that inclined surface, is the true shape, whereas the rest are not. And this gives you an overview of the complete process of getting your true shape, or the complete auxiliary view. Okay, so that completes our tutorial exercise, tutorial number 9. Okay, and once again, apologies for being late in uploading. Okay, I'll be shortly trying my level best to complete tutorial number 10. Okay, so in regards to this, if you have any questions, feel free to post it in the tutorial forum. Okay, and also this week we will be having 1 or 2 live tutorial sessions, okay, using the Big Blue Button software, and shortly I will be posting information regarding it. Okay, and as always, if you have any questions, feel free to drop an email with your respective teaching assistants and your teaching staff. Okay, I hope you found this video easy to follow. Okay, always feel free to go over it again and again. Okay, try your best, and if you have any questions, if you are stuck anywhere, feel free to ask us. Okay, and yes, again, it's a very good exercise it will be if you can try to draw this object out in AutoCAD. Okay, get the isometric in, and then you can use your own measurements as long as it is appearing proportional, and then try to project the auxiliary view from it. Then you will be able to see that the results you get are very much similar. Okay, thank you very much. Stay safe, and I will see you all soon in another new video. Vinaka.